start the technical discussions. As said, good afternoon and thanks for being with us today. This webinar was organized to open the discussion on the assessment and monitoring of soil health in the Asian region, looking at soil analysis in laboratories, but also using soil test kits in the field. The webinar was organized as part of the implementation strategy of the Asian Knowledge Hub on sustainable soil and land management in the region. And I would like to briefly introduce you to the Knowledge Hub before we proceed with the more technical discussions. Just a second that I share my screen again. Okay. Okay, I hope you can all see. So as I said, this webinar is organized as part of the Asian Knowledge Hub on sustainable soil and land management. The objectives of this hub are to facilitate the exchange of knowledge and experiences on sustainable soil and land management in the Asian region, to enhance the capacity of individuals and organizations in implementing sustainable soil and land management practices, to facilitate the identification of knowledge and technology gaps that can boost research and development activities, and to encourage the adoption of proven methods while inspiring innovation in sustainable soil and land management. Indeed, we really hope that by having these webinars, you get inspired, and that's why our slogan is share, learn, and inspire. No? So we have countries, but also international organizations sharing tools or experience strategies, whatever that they developed in their country or in their organization or institutions. And we hope that by sharing this with you, we feel inspired and maybe feel like either adopting them in your own country or institution, organization, or take them, adapt them, modify them, whatever, but just get good ideas to keep on with the promoting sustainable soil and land management in your country. Ultimately, this webinar series also aims to support project formulation and implementation activities. As I said, the Knowledge Hub, but also the webinar that we are attending today will report on countries' original engagements to assess, monitor, preserve, restore, or enhance soil health. And these have been coupled with contributions from the United Nations. If you feel like sharing your experience on this topic, but also other topics, please feel free to send me an email. I will send you the template to report on what you developed in your country or organization, and we can have it included in the hub. So as you can see, the hub itself was developed through a participatory approach that involved the public sector, non-profit sector, academic and research institutions, as well as international organizations. But the users of the hub are everybody, basically. Also the academia, farmers, local community extension agents, and also the private sector. The content in the hub is organized under 5 thematic areas that reflect the scope of the tools that they refer to. So we have scope 1 on soil assessment, monitoring and mapping. Scope 2 is on policy. Scope 3 is on investment. Scope 4 is on field activities. And scope 5 is on communication. This specific webinar was organized under scope 1, so soil assessment, monitoring and mapping. And today's objectives are those of breaking preconceptions and myths around the soil analysis, support countries on the development of reliable soil testing kits. And in this regard, we really would like to close the gap between soil test kits and the soil analysis. Then we would like to initiate a discussion, if you agree on the idea, let's see, to maybe have harmonized soil test kits at the regional level. And then we would really like to encourage a critical thinking regarding the integration of soil analysis in project formulation and executions, and brainstorm on regional essential tools for leveraging soil data and attract investments on the topic. So this was a brief introduction to the hub. I would like now to invite the first speakers of today, Ms. Nobmane Suvanang, that is a member of the Intergovernmental Technical Panel on Soil. She's actually representing Thailand within this group in the Global Soil Partnership and FAO. You might know her because she has also been the first chair of the Global Soil Laboratory Network, to take the floor and actually break the ice by telling us why should we care about soil analysis and data quality in decision making. So, Ms. Suvanang, I'm now passing you the floor.
Thank you, Lucrecia, for introducing me. Let me share my screen. Did you see my screen?
Yes, but we see the Zoom launch window.
So you see it?
Yes.
Okay, good. Okay, thank you very much to give me a chance to exchange during this webinar. My topic today is the importance of soil analysis and the data quality in the decision making. As you may all know about, the agriculture development is one of the most powerful tools to end the extreme poverty and feed a projected 9.7 billion people by 2050. Growth in the agriculture sector is 2 to 4 times more effective in raising income among the poorest compared to the other sectors. And food is the basic product of the agriculture. Because of the growth increasing of the population, it's estimated that by 2050, the world will need to increase its food output by around 70% in order to feed an ever-growing population. And it means that action needs to be taken to increase and diversify the fertilizer supply across the globe to strengthen food security systems and crop production. So we all know that soil is where food begins. Soil is a virtual resource. It provides us with the nutritious food and other products, as well as with clean water and the foraging habitat for the biodiversity. Agricultural soils play a crucial role in the food security and the climate change. And soils are also a key to tackling climate change as it captures and stores vast amount of the carbon, and also support and drives all of the life on Earth. So soils are also a key that will be the potential for the mitigation and the adaptation to the climate changing. You can see that if you have on your right hand side is the sustainable soil management, that you can do it, but if you do it in unsustainable management, you will have many problems about that. And being critical to achieving the Sustainable Development Goal of the United Nations, strengthening understanding of the property and process of the soil at national and regional scale is imperative. The necessity to realize the SDG by 2030 also inspire a greater sense of the responsibility and care of soils. Sustainable management of soil health is important to achieving several SDGs. Some of them is the SDG 3 for the good health and well-being, SDG 6 for the clean water and the sanitation, and SDG 13 for the climate action, SDG 15 for life on land, and more important, SDG 17 on the partnership for the goals. But soil is a black box, and our knowledge mostly comes from the soil analysis. In today's world, the testing data has become an indispensable tool for business in all sectors. In agriculture, the use of soil testing data has revolutionized the way farmers make decisions, allowing them to make informed choice and optimize the operation. Existing global documents like SSM from the FAO, IPCC reporting, or demonstrating the significant growth in the use of the lab test result as the key indicator for the monitoring and evaluating the changing from the practice and the decision making for understanding the practices and develop the action to be taken to improve the situation. So soil is very important because it supports for the accurate soil diagnosis and recommendation. Soil testing results can help farmers optimize their use of the resource, such as water and fertilizer. By analyzing soil data, farmers can determine the nutrient levels and adjust their fertilizer application to ensure that their crop receive the right amount of the nutrients. Similarly, by analyzing the soil moisture level, farmers can also optimize their irrigation schedule, reducing the water waste and also improve the crop health. The soil analysis are also support the identification of the research gaps and contribute to improve the quality, comparability, and reliability of the scientific data for sustainable soil management. The national data are crucial for the soil health monitoring at the national level. Key indicators of the national data such as nutrient budget, ecosystem services, carbon sequestration, farmer production, and the policy making by the government. At the international level, national data are the basis for the monitoring of the global targets, such as those of the 2030 agenda for the SDG. They are also used for the identification of most vulnerable and make global decisions. So data quality is very important because data quality is crucial to proper analytics, as it can be challenging due to the variability of many factors. For example, the competence of the lab staff, the regularly maintenance and calibration of the equipment used, and also the well-written document SOP, and also the quality control system that need to put in place, including the data management practices to be sure that the data is entered correct and that there are no area of omission. Since agriculture plays an important role in the economy, it is crucial that the data be useful and with a proper level of the quality for the decision-making process, planning activity, among others. Moreover, a lot of research money have been spent to develop new smart agriculture practices and or improve the management of soil for sustainable crop production. And the quality of the soil testing data will ensuring that the right data will be collected by for arriving at a decision within the design confidence constraint. But we need to note that accuracy must fit with the purpose. Accuracy can be different depending on the impact of your decision. If you are going to fly in the airplane, you are expected to have the high accuracy data because it will protect your life. But when filling your petrol in your car or waiting for your weight, this data may be not necessary to have very high accuracy data. So what is the quality mean? They have two terms. Actually, I would like to speak about these two terms in this speaking. Quality assurance and the quality control. In the production and the service sector, quality means meeting the customer's expectations. The quality data produced by the lab need to be accurate, high precision, and also fit for the purpose to meet the customer expectation. Quality assurance is a system of the overall management and systematic actions necessary to provide the adequate confidence that fit naturally into the workflow without disrupting your other important tasks. Quality control requires an active response to an issue. It is an operational techniques and activities that are carried out in a lab to ensure the quality of the analytical data produced. So I provide this figure because this figure is all of the life cycle of the lab testing that started from the farmer or the stakeholder sending the soil sample, and then end by the lab manager provide the reporting to the farmer or stakeholder. So in this overall system, you need to have the quality assurance program. But for the quality control, you need it on the analytical phase because you need to have to implement either the internal quality control or the external quality control. I cannot go. I don't know why. So why quality control is important? It's to safeguard the reputation, prevent testing results from being unreliable, and increase trust on the side of the clients. It's ensure that the lab look at the evidence-based data and research rather than the anecdotal observation to ensure that the service testing results live up to the standard. To make the lab environment safer, saving you and your employee from the injury, waste time, and legal troubles. Maintaining accurate and frequent checks of the lab sample testing through the quality control is vital to ensuring that testing is done right and that it produces accurate results for the efficiency use. Please remember that quality control encourages lab manager to keep quality in mind throughout the analytical process, which can help the lab manager achieve the desired level of the quality each time. The process of the quality control is for check the testing process that don't meet quality standard, correcting any problem and bringing down the testing process. And this quality control will increase the client satisfaction because it ensures that client receive the soil testing result free from the error or defected. When institutions recognize that they are producing high quality testing results that deliver value to the clients, it can improve overall institution morale. So to improve your quality process and results, I would suggest to do by the PDCA step. P is planning. Planning, define the scope and boundary of your quality improvement initiative. Understanding what you are trying to achieve, who are the stakeholders, what resource and constant access, and do by implement the process, what standard and expectation exists, any risk or opportunity that exists. Checking by monitoring process, it will be important to assess the effectiveness of the action taken using focus review and the audit process, and act any corrective action that is required and then recheck to be used that the solution has worked. This cycle is a continuous process, so the lab will begin again and again with the planning process to continue the improvement. So data quality for the decision making, I would like to provide you 2 examples when you have the wrong result that will lead to miss the management of the fertilizer. The overuse of the chemical fertilizer less the risk of the eutrophication either by the nitrate pollution of the groundwater. This table shows you about when you apply more fertilization, you have the risk that have more nitrate reaching to the groundwater or the water body, and that this will induce the eutrophication, and then the fish can be suffer because they lack of the oxygen. Another example is the overuse of the pre-fertilizer that increase the risk of the cadmium transfer to the food chain. The study from theory provide the content of the cadmium in the sedimentary and initial phosphate rock. And this contamination of the cadmium in the leafy vegetable can induce the mechanism of the cadmium toxicity on the human health. So what is the cost for the good quality? You need to pay for the staff training, such as precision in work, deduction of the waste. You need to maintain of the equipment to avoid any potential downtime. And you also need to implement the quality management system to be continuous review and optimize, and keep the base of the asset development in quality management system, and adopt new process improvement strategy. The last one, if you have more money, you also can regularly body accreditation. Lab can pay for a test system audit by a recognized regulatory body. Challenge of the global soil testing result, you have insufficient training on soil testing procedure and quality assurance system. indicate inadequate implementation of the quality control during the analysis, less awareness on the importance of the quality control and safety during the routine practice on soil testing, and more important, inadequate harmonized available soil data, poor soil data storage, database management, and insufficient data access infrastructure. So key success to improve the quality in the lab, you need to investment in capital for the personnel and quality management commitment, because it is a very important key. Frequency implement of the quality control during the analysis. And you need to raise awareness to your staff, because quality control is not only one people duty, but it's everyone duty. Change attitude of your daily routine analysis practices. My last sentence is that if your lab begin to neglect or not take quality control seriously, there will be a decline in the precision and the accuracy of the test result and the data collected. Thank you very much for your kind attention.
Many thanks, Ms. Suvanang. It was very good, and I think you very well also broke the ice and introduced today's topic of discussion. But now, well, on one side, I would like to invite participants to write their reflections and eventually their questions in the question and answer box that you see at the bottom of your screen. And on the other side, I would like actually to ask them, what do they think of the topic that you introduced? And for doing this, I have some polls, actually 5 polls with questions that I will start launching now. And by doing this, let's see what people think. So let me start with the first poll. I hope you see it on screen. You should have this window showing up in the middle of your screen. There will be 5 of these now and some more later today and tomorrow. The question is the following: do you trust soil test kits? Possible answers are yes for all soil parameters, or yes, but only locally developed kits, or only for fertilizers recommendations. Otherwise, we get to not much. So we don't really trust soil test kits, but we don't have any good soil laboratory in your country, or you don't trust soil test kits at all. No matter what, you don't trust them. So these are the answer, possible answers. This is the question. I will close the poll as soon as we reach majority, or as soon as we have a dominant answer. I will give a few more seconds to answer this question. Okay, I'm about to close it, so please hurry up. Okay, here are the results. So the majority said that they trust soil test kits only for fertilizers recommendations, or otherwise for all soil parameters. Very interesting. We also have some dominant preference for, well, they don't trust soil test kits, but they have no other options in the country. And last, they trust only locally developed kits or no kits at all. Now, let me get to the second question that I have for today that you should be seeing on screen now. Do you think that soil test kits can replace soil laboratory analysis? Yes, no, or only for some purposes, like fertilizer recommendations? Very interesting results. I have a preview already. Please hurry to answer. I will close the poll in a few seconds. Okay, the dominant answer is only for some purposes like fertilizer recommendations. Otherwise, there is also quite a majority that says no. So soil test kits cannot replace soil laboratory analysis. Let me get you to the third question for today. Do you think it is important to compare data from laboratories and soil test kits? Possible answers are yes, to ensure that data are comparable and reliable. Yes, but only if the laboratory is qualified. No, because we do not know if we can trust data from the laboratory either, or you never thought about it. That's also fine. Don't worry, don't be shy. Results are anonymous. Let's see. I'm about to close the poll. Okay, there is a large majority that said yes, to ensure that data are comparable and reliable. As I told you, I have 5 questions in total. So now I bring you to the 4 questions that I don't know why I cannot launch. Let me see what happened here. Okay, 4 questions. Are soil test kits available in your country? Yes, they are locally produced. Yes, we import them and then adapt them to local conditions. Or yes, we import them and use them as they are. Or no, you don't use soil test kits at all. Let's see. I will close the poll in a few seconds. Please hurry up to vote. Okay. So the dominant answer is yes, you have locally produced soil test kits. Otherwise, there is also like a preference for not using soil test kits at all. Last question. Do you think that soil test kits can be used for national monitoring activities on soil health? Here, the possible answers are yes, for all parameters, and we are already using them for this purpose. I'm sorry if you cannot see the whole answer, maybe you can just stretch the window. Second answer is yes, only for some parameters, and we are already using them for this purpose. Third answer is yes, but we are not using them for this purpose yet. Fourth answer, no. National monitoring activities should rely on soil laboratory analysis because decision makers require highly reliable data. I hope the answers are clear. I will close the poll in a few seconds. So please hurry up to make your selection. Okay, so here we have 2 dominant answers. The first one is yes, only for some parameters, and we are already using them for this purpose. This is very interesting to know. And the second one is no, because national monitoring activities should rely on soil laboratory analysis only. Oh, sorry, you couldn't see. Okay. Thank you very much. I hope you warmed up and are ready for the discussion. As I said, you are welcome to interact with the panelists anytime by writing in the question and answer box, interact with the other participants using, the question and answer box if you want, but also the chat box. Otherwise, please feel free to raise your hand and I will enable you to talk as the time for discussion comes. I'm kindly asking the panelists to please keep an eye on the question and answer. Indeed, Noc, there is already a question. I think it's for you. I didn't read it, but please help us in answering the question. Now, many thanks to you all for actively participating in this exercise. And as I said, there will be a couple more polls, but also game during this webinar. So please keep ready and stay attentive. I'm now passing the floor to Mr. Filippo Benedetti, coordinator of the Global Soil Laboratory Network, and to Mr. Pushajet Lokpal Chowdhury, that is the chair of the Asian Soil Laboratory Network, SILNET. And dear Filippo, dear Chowdhury, the floor is yours.
Thanks a lot, Lucrezia. Thanks for inviting us. Good morning to all participants from Rome. I'm really happy and honored to be with you today to discuss about this topic about the role of soil laboratories and soil testing kits, especially in the Asian region. As Lucrezia mentioned, I'm coordinating the Global Soil Laboratory Network, GLOSOLAN, and with me today there is Mr. Pushpajet Chowdhury, who is the new chair of SILNET, who will share with me the presentation. I will start by giving a little bit of introduction about GLOSOLAN. Yes. Why soil laboratories are important? This was already explained by Nokmane Suvanang. Basically, soil laboratories are is the place where soil become numbers, become data. And as soil data are very important for digital soil mapping, to make decisions, to make recommendation for farmers to decide how much fertilizer to apply in the soils and how to manage the soils, is very important to have accurate and precise data. This is why GLOSOLAN was established by FAO and its Global Soil Partnership in 2017. And it started with very few committed laboratories, and thanks to the voluntary commitment of its members, the network increased and enlarged a lot, and today counts around 1,000 soil testing institutions from around 160 countries worldwide. So it's a great success because of the commitment of its members, because of the need to have soil testing institution, and because all together laboratories can improve the analytical capacity and help each other. And this is how GLOSOLAN is structured. Of course, it's a global network, so it works at a global scale. But in order to better implement and tackle local problems and downscale its activities, several regional soil laboratory networks have been established, and also national soil laboratory networks, as you can see in the map here on the left. So for instance, there is a soil laboratory network for Asia, which is called SILNET, and a regional soil laboratory network for the Pacific, which is called ASPAC. And as I mentioned, everything is done from using a bottom-up approach, of course, a participative approach, meaning that every year laboratories meet, decide what are the priorities of the network at national, regional, at global scale, and the work plan is developed and implemented accordingly. So basically, those labs which are a little bit more advanced are there to support those labs which still need to be improved to improve their quality of the analysis, to enlarge the kind of analysis they do, to improve their services. And of course, GLOSOLAN is a big success thanks to the commitment of all its members and its partners and its regional networks. And then you may see, and as you may see here, there are key partners for GLOSOLAN also in the Asia and the Pacific region. What are the main areas of work of the network? Standard operating procedures, of course, the harmonization of these SOPs, trainings, awareness raising, so capacity building on several topics related to soil analysis, quality control. So GLOSOLAN support the organization and organize itself Interlaboratory Proficiency Test, also called PTs, and it works with other networks. So there are several other technical networks within the GSP, the Global Soil Partnership on Soil Biodiversity, salt-affected soils, soil pollution, and GLOSONAL works with all of them in order to develop together material harmonized procedures on those parameters. So parameters to determine salt content in soils, heavy metals content in soils, biological indicators, and so on. Also, GLOSONAL has tried to support countries in exchange soil samples worldwide to the launch of this simple database, which basically reports import regulation for each country about soil samples. Why? Because it's important to facilitate the exchange of samples for the PTs, so to allow countries and laboratories to organize and participate to proficiency tests, and also to the exchange of samples for research purposes. So all this is done also, all the work of the network is also shared with the scientific communities. And so GLOSONAL is also working on publishing papers and other scientific documents. Just to give you an overview of the work done by GLOSONAL recently, this is a slide about the recent SOPs that have been published, which are not only limiting to chemical parameters, but includes also heavy metals, physical properties, biological parameters of soils. So these procedures have been harmonized thanks to the support of GLOSONAL members involving many laboratories, harmonizing the procedures already adopted worldwide into regional and global procedures, harmonized procedures. As you can see in the bottom left box, the last SOPs that have been published by GLOSONAL concern soil respiration rate of soils, soil moisture, biogravimetric method, CEC, so cation exchange capacity and exchangeable basis, available micronutrients and heavy metals by DTPA, heavy metals by quasi-total, by acidic digestion, and soil bulk density. Next SOPs to be published that are almost there are boron by hot water extraction, and particulate organic carbon by physical fractionation, and microbial biomass. These are about to be published soon. But indeed, I strongly encourage you to have a look to these procedures, to these documents, which are available on the GLOSONAL website for free in multiple languages, and includes not only the procedural details and instructions about how to perform the procedures, but also information on quality assurance and quality control, health and safety, sometimes also interpretation of the results. So it's very important that these procedures are adopted so that data among different laboratories, especially in different countries, are more comparable, because in this case, laboratories will use the same procedure. And of course, if you find anything you would like to be improved in this SOPs, please let us know, because we revise regularly such protocols. As I mentioned, these are the kind of information reported in the documents. So again, a kind of attention is also paid for the sustainability of methods. So where there are multiple methods for the same soil parameters, we try to highlight those parameters which require less reagents, less strong reagents, or for instance, the level of equipment of technology for the equipment involved in the procedures, and the overall risk for the staff, laboratory staff handling the procedures, and the environmental risk linked to the disposal of the reagents after analysis. And of course, we try to facilitate adoption of the SOPs, and I stress a lot the importance of the SOPs, because this is something very important for laboratories. We try to facilitate the adoption by, of course, making them available on the FAO website for free, but also translating them in multiple languages and developing training videos for these SOPs. This is an example, for instance. SOPs are not only translated in the UN official languages, but also may be translated in the local languages, the national languages. So this is an example of the SOPs of Glossoland translated in Thai language on phosphorus, on carbon, and on pH of soil. This is how the Glossoland web page look like. As you can see, you can just click on the language you are interested in, and you can download the same protocol in different languages. Regarding capacity building, many efforts are being done to support laboratories to improve their quality of their measurements, to initiate the measurement of new parameters, especially regarding physical and biological parameters of soils. This is done by a series of in-person training sessions that have been implemented recently. So last year in Djibouti, then in Uzbekistan. In May, there was a workshop on the measurement of salt-affected soils. There was a big training for sub-Saharan countries in Senegal just last week. And of course, there are webinars that have been developed, especially during the COVID times, and many guidelines on how to set up in your laboratories, on how to implement the SOPs, quality control in the laboratory, health and safety, soil spectroscopy, calibration of laboratory equipment, and many other topics. All this material is available on the Glossoland website, and I really encourage you to have a look at it. Regarding quality control, we cannot not talk about the PTs. As I mentioned, Glossoland organize many PTs and support countries in organizing their own PTs. And this is an example on the last global PT that Glossoland organized in 2021, 2022. Basically, over 240 laboratories participated, many of which from the Asia and some also from the Pacific. The PT focused on carbon, nitrogen, and phosphorus, and a series of a set made up by 10 samples have been distributed to laboratories. Also thanks to the support of the BGS from UK and IRD from France, we were able to analyze such results and have an idea on what is the level of proficiency and accuracy of soil laboratories worldwide. This is the Glossoland also initiative on spectroscopy. As I mentioned, we do not limit only to soil wet chemistry, but also to dry chemistry, so spectroscopy. There's a series of training material that have been developed to build the capacity of the use of spectroscopy. There is a series of webinars about several topics linked to soil spectral analysis, from the building of the spectral library up to the measurement of the samples. And this involves top experts, so I really encourage you again to have a look at these recordings. And there is this working group on the capacity development for soil spectroscopy, Soil SpecNet. But what is when we talk about soil laboratory soil testing kits, also considering what I told you, what is ultimately the difference? Of course, laboratories, as I mentioned, can rely on even the newest technology like spectroscopy, can guarantee a calibration of the instruments, can work a lot on the quality, on the inter-laboratory comparisons, on the quality of the measurements. So laboratories can provide information on the quality of the analysis, but sometimes laboratories are not easily accessible by farmers and other customers. So that, besides talking about on the difference between quantitative and qualitative measurements that can be done by soil testing kits on the field, the point is that many times there are very few laboratories in some countries. So the analytical capacity of a country is not enough to cover the demand. So that soil testing kits play a big role for that, because they can really help farmers and customers to measure soil properties on the field. And of course, distance to laboratories, which many times are located only in big cities, far from the farms, from the fields where analysis is needed. And there is a shipping cost to be covered by farmers. And the cost of analysis itself. Sometimes farmers cannot afford to cover the cost of analysis, and they have to choose between a cost of analysis and a bag of fertilizers, for instance. And of course, the choice will go for the fertilizers most of the times, because this can be seen as a best investment. But of course, knowing the soil is very important, because only by analyzing the soils, by testing them in the lab or in the field, you may have a better overview of which kind of fertilizer you should apply, when, in which amount, in which components, and so on. And also confidence in the results. So some laboratories have problems with precision. They have problems with even sample storage, as you may see in this picture. We have to build the capacity of laboratories to provide accurate data, because it is important that they are providing accurate results with confidence, so that farmers will be more confident in sharing their samples with laboratories and invest in soil analysis in the future. And of course, sometimes there is a lack of experience on the testing, what I call testing culture, meaning that farmers are not really aware of what are the benefits of soil testing. So these are all points that I also would like to share with you for the discussion later on. But now I would like to continue the presentation by focusing on the activities of soil laboratories in the Asian region, so within the SILNET network. And to do that, I would like to invite the chair of SILNET, Pushpa Jet, to take the floor. I will maybe continue sharing my screen if it's fine with you, Pushpa Jet, and you can tell me when you want me to change slide.
Yeah, you can change the slide. Am I audible? Yeah. Okay. So thank you, Filippo, for sharing the slides, and also for handing over the presentation. Firstly, I would like to thank all the members for entrusting and bestowing your support and selecting me and Derek for the chair and the vice chair for the governance in 2023 to 25. And since its inception in 2017, now we have reached a good figure of 140 registered labs across 19 Asian countries. And thanks for all of the team, all the laboratories who have registered under this network. And nevertheless, the Super 6 steering committee members who have been virtually getting in touch with all the members, all the laboratories, and getting the harmonized methods, and also streamlining all the objectives of SILNET. There has been a steep growth, after you see from the graph, from after 2020, and it is having an escalation growth across. So that's a good move from the SILNET perspective. Next. So these are some of the main activities, like the regional PT launched in 2018. Also, the inter-laboratory comparison network report is also released and available with everyone, and across anyone can share it. Contribution to the GLOSALON activities being a you can say, network. We have been doing the webinars, the training videos, and the SOPs have been so far harmonized, are also available. Global assessment on laboratory capacities and needs is also one of the mandate. And you can see the pictures wherein some of the laboratories have received the equipments. A global map indicating a geo-tagged registered laboratory is also seen across. And recently, we have the meeting in Vietnam, wherein Lucrezia and led by Lucrezia and other members like Nob and Christian Atman, everyone, of course, nevertheless, the grateful contribution of Dr. Gina. And we have decided for the Asian Soil Health Framework, which will be taking place in some of the pilot countries where the action framework already exists. So there we are going for a piloting study on initial basis. Next. So the identification of country where the pilot implementation can be done. So next, please. So also congratulate Dr. Gina and the team of Bureau of Soil and Water Management of Philippines, who was a PT provider and who was the PT leader in 2023, steering the whole process. And we had targeted the parameters like organic carbon, pH, available phosphorus, total nitrogen, exchangeable potassium, and particle size distribution. Almost about 125 laboratories have contributed and participated by sharing their result. It was a very well entrusted blindfolded SealNet PT, followed by all the statistical analysis, and very much well guided by Nop and Christian as members or experts for the PT. So, and the last it will be getting launched in 2023. We will be taking forward in line with the Glossaline protocols. Yeah, so these will be the targeted soil parameters. Will be registered and they will be getting sample. Next, please. So thank you, and I encourage all the members to today they can contribute and also brainstorm across the soil laboratory, like the kits, the soil test kits, which will be discussed. I like congratulate all the participants who are willingly joined and will giving their presentations. All the members are free to exchange their thoughts. Thank you for your kind patience. Yeah.
Thank you very much, Pushajit, and thank you very much, Filippo. I saw that there were some questions in the question and answer box on Glossaline, so on this presentation. I encourage all participants to keep on asking their question in there, but maybe I would like, Filippo, if you can, or Pushajit, to answer one of these questions live, that is the one related to the PT that you might organize in the region in 2024. I think this is important to answer live.
Yes, let me get it with I already typed the answer in the box, but maybe I can give more details now. So within the next PTs, so this year 2023 have been dedicated to regional PTs. So as Pushajit mentioned, there is a SealNet PT, so a PT for the Asian laboratories that will be launched in the upcoming weeks. So we are about to sterilize the samples, and then this will be distributed. So soon we will launch a call to participate to this PT. The good point is that the colleagues in the Philippines, who I thank a lot, prepared a huge amount of samples so that we can ensure the participation of many laboratories in the region. This is very good. In the same time, PTs are taking place in Eurasia, in the Africa region, in the NINA region, so Near East and North Africa region. But next year, 2024, a new global PT will be launched by Glossaline, targeting those laboratories which already adopt internal quality control practices. So we will target laboratories that already have internal quality control practices, because what is the message that we should share with laboratories? The first thing to be done at laboratory scale is to run internal reference material. It is to have a severe calibration process within the laboratories. Once internal quality control processes are adopted, laboratories should join inter-laboratory comparisons. So next year, Global PT will be targeting several parameters, not only chemical, so carbon, phosphorus, nitrogen, and so, pH as well, heavy metals, we will try to target that as well, if possible, and particle size distribution, most likely. So these are the procedures that the parameters we will like to launch next year, but this will be discussed also in the next Glossaline meeting from the 21st to the 23rd of November. The next PTs will be discussed there. So I invite laboratories to join also the Glossaline meeting soon. I will share the invitation in the upcoming days. Thanks.
Many thanks, Filippo. It is now time to talk about soil test kits, and today we have the honor to have 4 countries talking to us about their national developed soil test kits, how they look like and how they work. And especially also we will look at what parameters they can measure and for what purpose. No? That links back to what Ms. Suvanang told us at the beginning of this webinar. So now allow me to give the floor to the first speaker that is from Thailand. It's Ms. Kamarin Nimluarat. I'm very sorry for my bad pronunciation. soil scientist from the Office of Science for Land Development, Soil Mineralogy, and Soil Micromorphology Research Division of the Land Development Department of the Government of Thailand. So, Ms. Kamarin, the floor is yours.
Thank you, Lucrecia. Let me share my screen.
We can see it clear.
Yes, thank you. Thank you. My name is Kamarin Nimnwanrat. I'm soil scientist from Land Development Department from Thailand. For today, I would like to present two parts. First, the history of LDD soil test kit, and second, I will talk about method and development of LDD test kit. Land Development Department, or LDD, has a main mission to analyze soil for farmers so that farmers can manage their soil and add fertilizer correctly and appropriately. Normally, LDD provide many channels of soil analysis service to farmers for free. First way, soil analysis at standard laboratories, which are available at 30 locations. Results were received within 45 days. And second way, the mobile soil analysis units that go into farmer areas and give advice to farmers. Results were received within a day. And in the year 2011 to 2012, Thai farmers faces the difficulty of the capital of agricultural production as the price of important chemical fertilizers has increased dramatically. However, most Thai farmers could not use chemical fertilizers effectively. The Committee of Promoting Effective Use of Fertilizers of Reducing Costs of Agricultural Productions assigned LDD to in charge this matter, especially the rapid, easy, and reliable soil testing. LDD assigned the Office of Science for Land Development to conduct research on a prototype of quick soil attribute detection as soil pH, nitrogen, phosphorus, and potassium. We produce few soil testing kits and compare soil analysis results from soil testing kit with soil analysis results from soil laboratories. And that is the beginning of the soil testing kit. In 2011, the first soil LDD test kit production was 400 units, which were allocated to soil analysis groups of Land Development Department, Regional Office 1 to 12, and Land Development Department station in 77 provinces under project, promoting effective use of fertilizers of reducing costs of agricultural production. Each province would get 4 to 5 units to be used for testing and analyzing soil in the area of their responsibility. LDD support the initial budget about 3 million baht is about 85,000 US dollar. For provide necessary items such as pH meter, dispenser, dehumidifier, chemical reagent, and equipment for develop a prototype kits. In 2013, LDD soil test kit was an official announcement of Land Development Department established day. The development of LDD test kit began with the pH and NPK kits. And then around 2016, EC kits has begun to be product for checking soil salinity in northeastern region and or in inland saline soils. After that, we produce soil testing kit under various projects continuously because the Ministry of Agriculture and cooperatives would like farmers and the general public to be aware of the importance of soil analysis. Our major task is to analyze soil in laboratories and mobile laboratories that LDD is already implementing. However, this service is not enough for farmers in whole country. Farmers cannot get soil analysis results before the planting season. To expand our service to farmers, we develop and produce LDD test kit, which is a field soil analysis method in order to farmers get the results on time. Currently, Land Development Department produce soil testing kit to support other agencies, including educational institutions, the private sector or companies, other agencies, and foreign cooperation. The principle and method developed from the laboratory as follows. The first are in NPK test kit, measuring nitrogen content in soil samples using the principle of measuring organic matter in the soil, adapted from Walkley and Black method. For measure phosphorus content in soil sample using the principle of extracting of soil sample solution with a solution Merlich 1. Then add a drop of solution to make the color using molybdenum blue method. For measure potassium content in soil sample using the principle of extracting the soil sample solution with a solution Merlich 1. Then add a drop of solution to make a precipitate using turbidimetric method. For measuring pH of soil sample using the principle of color matching or coloring metric method of the mix indicator that change according to the concentration of hydrogen ions in the soil sample and compare with standard color chart sheets. The level of resolution of the pH value is different 0.5 units in the range 3.5 to 8.5. And the last, measuring soil salinity using the principle of precipitation titration method was applied. Is the use of silver nitrate. It is used as a coagulant. It is commonly used in the analysis to quantify anions such as halides, especially chlorides. This method is called Morse method. This is the timeline for develop pH test kit. It took about 2 years to develop the soil test kit. Start from file information, test indicator in laboratory, development, color chart and tool for easy handling, testing field, and finally produce it. This is the comparison of LDD test kit and laboratory with various types of soil, such as acidic soil, light soil, and saline soil. The result revealed that the pH of LDD test kit was approximate 50% equal to the soil analysis results in laboratory, and the NPK of LDD test kit was equal to the result of soil analysis in the laboratory is approximate 80%. And for LDD soil pH test kit received petty patents. The protection period for petty patent is during 2019 to present in Thailand. And next, I will tell you about the development of the LDD soil testing kit model. Get started with the soil pH. Mainly, we have changed the style of the bag to make it more modern and more beautiful. For NPK test kit, the first version is a beautiful black box with storage compartment like a cosmetic box, but the cost is quite high and weighs a lot. The second version is a foam box and keep a light weight, but there is a disadvantage. It is not proportional, as it takes time to block the channel with plastic board one by one bag. And next, in 2016, the third version of the green bag is lightweight and has compartment, but the disadvantage is that the bag is made from nylon fabric, does not hold its shape, and get dirty easily when it wet, especially liquid leak during transportation. And the last, in 2021, we developed new blue bag that made of plastic, more proportional device locking compartment, and is used until the present day. At present, land development departments have 3 types of soil testing kit. pH test kit can test 60 to 80 samples. The cost price is about 400 baht. NPK test kit can test 50 samples. Cost price is about 2,000 baht. And EC test kit can test 30 samples, and the cost price is 650 baht, 650 baht. In addition to the bag set, we also produce demonstration kit for display at exhibitions or at teaching materials. In 2017. We have developed and improved it until we have a demo set that we currently use in present. There has been continuous improvement and development of soil testing kit to make use more convenient, such as improve the process of measure nitrogen in soil by reduce cumbersome steps, eliminate and problem by refraining from using quick expire solution. However, the results are as accurate as before. We improve NPK unit to be stronger and more beautiful and increase the analysis of the number of soil samples in each unit and increase the production of additives. We changed to viewing NPK levels by using a chart plate instead of using liquid to speed up the production of soil testing kit and make the bag lighter. The color calibration chart of the pH unit has been redesigned to make a color grading easier and add recommendation for soil improvement. And when the farmer have testing the soil, they can use the program to calculate fertilizer based on soil analysis value in order to apply fertilizer correctly and save costs. And finally, I would like to show a picture of activity in the production of soil testing kit. It looks like a factory. And this is the picture to use soil test kit for soil testing by soil volunteer doctor and LDD staff. Thank you for your attention.
Thank you very much, dear Kamarin. It was very interesting, and indeed you already have some questions to answer in the question and answer box, please. The plan for this session is the following. We will run all presentations one after the other. Of course, participants are kindly asked to already start asking their question in the question and answer box. And at the end, after all presentations, we will have a comprehensive discussion. So thanks again, Ms. Kamarin. Very nice presentation. I would just now like to give the floor to the next speaker that is from India. So actually, India has 2 presentations, one from from Dr. Sanjay Srivastava and one from Dr. S.R. Mohanty. So I don't know who would like to go first. Maybe Sanjay, you go first. I have you first in the agenda.
Yes, I can.
Okay, so both speakers are from ICAR, Indian Institute of Soil Science. And as I said, the first speaker is Dr. Srivastava, Sanjay Srivastava, that will talk about the soil test kit. And you pronounce it because I will just spare everybody from my terrible pronunciation on this. Mrida Pariksak.
So should I start, Lucrecia?
Yes, please. Thanks.
So can you hear me, and whether the slide is visible?
Yes, it's perfect.
Okay, thank you. Good morning and good afternoon, everybody. I'm going to make the presentation on the soil test kit, which we call Mrida Parikshak. So this Mrida Parikshak, basically it is a word in Hindi language, which is used in India. Mrida means soil and Parikshak means examiner. So we basically refer this as soil examiner. This Mrida Parikshak was actually, the first version was made in the year 2015. And the kit is based on wet chemistry. And we measure 15 soil parameters. And we don't call it a kit. We call it as mini lab, because we try to simulate the laboratory conditions in the form of a kit. That means I would be showing you, we are having shakers, we are having hot plates, we are having weighing balance, and we also have a customized colorimeter. So the difference is that most of the analysis we have converted into colorimetric analysis that we are measuring, I would say semi-quantitatively, not with as much precision as we measure in the laboratory. It looks like this. You can see top left, there is a hot plate. And then you can also see somewhere in the center, it is the shaker top. It is a double-decker shaker. That means there are two trays. So two shaking you can do simultaneously. That means phosphorus and potassium, for example. And then at top right, you can see Mrida Parikshak. This is the main customized colorimeter where we do the measurements. And on bottom, you can see these sieves are also there. And bottom left, you can see small weighing balance. Looks like a calculator or a cell phone, but it is a weighing balance. So I would say that not all the things are actually made in our institute. Some of these things we have outsourced also, but most of the equipments like customized colorimeter, shaker, and this hot plate, we have made in our institute. And we have also tested for the soil analysis parameters. And you can see a host of chemicals are also there, filter paper, and so many things are there. So it is a complete kit or mini lab by which you can do the analysis. So you can see these are the parameters: pH, electrical conductivity, organic carbon, available nitrogen, phosphorus, potassium, sulfur, zinc, iron, boron. In the first version, into 2015, we made with these parameters, and later on, available copper, magnesium, manganese, gypsum requirement, and lime requirement, and calcareousness. These parameters were added in the subsequent version that we launched in 2016. Not able to change it. I don't know. There is something. I'm not able to change the slide. Oh, yes. It has come. Sorry for the delay. So this is the main equipment you can see. And we see it. How many samples one can test in a day actually depends on so many things based on your sample, analysis program, and how well you actually make entire system sequencing one followed by another. So, but what we have actually observed and we have tested that one can test 15 samples in a day for 14 parameters. Only for boron analysis we cannot do because there is a lot of work is required in boron analysis. You have to heat it and then you have to develop the color and so many things are there. But otherwise 15 samples can be estimated.
ว่าเราสามารถเขาสามารถเอา LED test kit ได้ไหม
So this is the sequence of operation. As I told you, for most of the parameters, we are following the colorimetric analysis. And as you can see, the first step is the weighing. Then you have to transfer and add reagent. And then you have to shake. Shaking, that means you have to extract. Then you have to do the filtration. Then 5 is done. You have to again transfer to another vessel. And then you have to add reagent for development of color. And then you put it in cuvette and put the cuvette in this colorimeter, which we call as the Smart Soil Probe. And then you can read the results. So this is the sequence of operation in this kit. And after once you get the soil analysis value, then you have to select the soil and select the crop. And you can then get the even the fertilizer recommendations you can get. And we have also put SIM cards. Some SIM is inserted in this Smart Pro. So at least to the operator and to other 5 people, we can send these results on the mobile phone. And from their mobile phone, one can send to the farmer's mobile. So this is how this kit works. It was developed, as I told you, in 2015, we developed this mini lab, and it was done in collaboration with an industry, scientists, technicians from our institutes, and also some experts from the industry, particularly those who were experts in electronics. They were involved in the development of this mini lab. And I have already told you colorimetric or turbidimetric methods were developed for organic carbon, copper, zinc, manganese, and for others, for example, phosphorus, sulfur, and boron. Already we are using colorimetric methods in the laboratory, in the conventional laboratories. Already colorimetric methods are used. Nitrogen we are not estimating, we are calculating actually based on the organic carbon result and by feeding certain soil texture data and rainfall data. That we have already fed in the equipment because we know the information about India. So based on those, we have developed some relationship, and from that relationship, we calculate nitrogen, available nitrogen, and we display. pH and EC are measured by their respective probes, as you measure in the laboratory. And gypsum requirement and lime requirement are also based on pH measurement. So as you can see that most of the estimations are colorimetric and some are probe based. And this is the comparison of results. This is of course long back we did this comparison from the laboratory. We have compared from for example, organic carbon, we have compared with Walkley Black because Walkley Black method we have used for the estimation of organic carbon. I am showing a result of only one parameter, but more or less the results are there. 85 to 90% matching is there with the laboratory, except zinc and potassium in certain conditions. So we don't recommend zinc and potassium if the soils are calcareous. There the deviations can be more. We have also fed the soil test crop response calibration equations. And for 8 important crops that are grown in India, we have put this relationship, and one can get the fertilizer recommendation also for these important crops and for the predefined target values, whatever yield target that you want to take. And for micronutrients, we are using the critical level approach. That means based on certain critical level, below that critical level, if the results are coming, then we recommend the fertilizers. Otherwise, we don't recommend the fertilizers. The most important thing for this kit or mini lab is the instructions must be followed in letter and spirit. There is a manual that we have provided with this kit. And because some of the procedures, even though we are trying to simulate the laboratory conditions, but this is kit, and we cannot develop color if we follow the extraction as we are doing in the laboratory. So for the extraction of nutrients, for certain nutrients, we have used different extractant other than the laboratory. And that is why, the results we have actually compared with the laboratory, and we have put certain empirical relationship inside that machine to actually display the results that is comparable to laboratory. So if these instructions are not followed, then you can get different results also. So that is very important for this mini lab. And it is mainly developed for Indian conditions, for Indian soils. As I told you that these relationship, the fertilizer and all these things we have put for Indian, for 8 crops grown in India. There is a lot of material on this mini lab available on YouTube. But unfortunately, most of the videos that they are in Hindi, but we will see, we are trying to make some video that is in English language also. As far as the I have not made the slide for the price or the costing of these kits, but I was just calculating the kit that is available in market that costs around for the development of kit, we spent around $30,000 US. 30,000 US dollars. And the kit is available at 1,700 rupees, 17,000 rupees. If you divide it by 80, you will get US dollar. So 70,000 divided by 80, that would be the price in US dollar for this kit. And for 100 soil sample analysis, again, around, I'm sorry, I did a mistake. For price of the kit, it is 86,000 rupees. So 86,000 divided by 80. So you can say, roughly you can calculate in US dollars. And for refill, it is 17,000 divided by 80. So that is in US dollar. So that is the price of this kit. And this kit was actually used in government soil health card schemes also, because the scheme was launched in 2015. At that time, we did not have laboratory infrastructure. So at that time, there was a need to develop some kit which is cheaply available to the farmers, not that costly. So that was the main reason, that was the main motivation behind development of this kit. So now we have sold around 10,000 kits to different Indian our soil departments, and there is a mixed response. Of course, the kit is working well in many cases. However, under different soil situations, in some soil situations, particularly now, I am of the view that those soils that are having pH below 5.5 or the soils that are having pH above 8.5, so we don't recommend now this kit for those soils. But for normal pH soils, the kit works if the instructions are followed. So thank you very much. That is all I wanted to say. Thank you.
Thank you very much, Sanjay. Now I would like to give the floor to Dr. Mohanty, that will actually talk to us about biological soil health kit. I'm kindly asking the speakers to be mindful with the time, otherwise we will not make it in time to finish all items in today's agenda. Dr. Mohanty, the floor is yours. And Sanjay, there are a few questions already for you in the question and answer box, please.
Very good day to all of you. Are you able to see my screen?
Yes, but not in presentation mode.
Okay. It's okay now?
Yes.
Thank you, Lucreza, for giving me this opportunity. I'm going to present the soil biological health kit, which is developed by our institute. And previously, all the speakers, they demonstrated the different kits, but those are all highlighting the soil physical and chemical properties, but not on the soil biological properties. So this is the kit that is only focusing on the soil biological health of the soil. So this kit is developed by a project. It is called All India Network Project on Soil biodiversity and biofertilizers. And we have a center at Tamil Nadu, which is the southern part of India. There, with collaboration with that center, we have developed this kit. This kit contains, you can see the picture of the kit. It contains the 4 units. One unit contains a jar and one indicator gel and the instruction manual. In addition to that, we also have a sachet of chemicals that we need for analysis of the kit for the soil health. So what are the specifications of this kit? One is that it measures soil biological property. It measures soil biological properties through microbial respiration. And when there is a microbial respiration, there is carbon dioxide produced. And that carbon dioxide reacts with the gel and it gives a color. And that color is monitored. And that's how we get some indication of the soil health. And farmers can use this kit by themselves. There is no need of extra instrument required. Time required about 8 hours, and one kit can be used for 2 times. The mechanism is here I have illustrated. One is that when you add the soil to that container, and there is development of the CO2 through microbial respiration, and you get different kind of color on the gel. And that color gel can be checked with a reference card. And depending upon the color, we can score the health of the soil. Here I have showing about the SOP, like standard operating procedure, how we can proceed towards the measurement of soil biological health. The first step is to take about 100 grams of soil and add about 5 grams glucose and 1 gram of urea. Then mix it and take about 60 grams of soil and put it in the container. And to that, we add about 20 ml of water. Then put that gel, that indicator gel. Then close that lid. And then after keeping the container about 6 to 8 hours, we get the color. So that color can give the indication of the soil health. So this is the result of what we get from the kit. If the score is about 1 to 2, that means the soil quality is poor, and it needs organic amendments, mulching, minimum tillage, all these things. If the score is about 3 to 4, then the soil score will be the average, and if the score is about 5 to 6, the soil is in good quality. This is a qualitative indicator of the soil biological health. The kit was developed in 2022, that means last year, and we came out with the standardization, like if the container having about 5 to 10 milligram of CO2, that means that will indicate low. If it is 10 to 20 milligram of CO2, then it is medium, and it's 20 to 25 milligram CO2, then it's high or good quality of soil. Before coming or finalizing the quality of the product, so we tested or evaluated the kit in several long-term fertilizer experiments that is running throughout the India, and we compared the soil biological quality index of the soils with the integrated nutrient, organic manure, and inorganic fertilizer, as well as non-control, and we could find about more than 0.8 correlation with all kinds of soils collected in southern part of India. Recently, we distributed about 400 kits to different districts, different farmers located at the different districts in the Tamil Nadu, which is the southern part of India. And you can see how the farmers are getting trained how to use this kit. And we collected the data from all 400 farmers field. And they use this kit in different kinds of crops, vegetables, as well as rice, sugarcane, sorghum, and all kinds of vegetables. And we collected the data from the 115 farmers about the usability of the kit, like whether they're satisfied or not. We can see here that although we say that this can measure only CO2, but we get a very good correlation with the soil organic carbon, microbial biomass carbon, dehydrogenase activity, and microbial count, all these soil biological quality indices. So this is a different kinds of correlation indices all over the different districts of southern part of India. This shelf life of the that indicator is about 45 days. That means if the kit can be kept under the room conditions, like 25 to 30 degrees centigrade, without any precautions, then it can stay up to 45 days. And farmers are very happy that it is very cheap, and they can use it within 1.5 months of the purchase. Well, we got the feedbacks from the farmers. They rated this kit 4.25 out of 5. Total number of farmers, they gave their comment that it is very good and they're going to use this kit in their future. Thank you very much for your kind attention and giving me this opportunity. Thank you.
Thank you very much, Dr. Mohanty. As I said also for the other panelists, please keep an eye on the question and answer box, because your presentation was very, very interesting and quite unique, because you deal with the soil biological parameters, no? Quite unique in terms of soil test kits. Sanjay, please have a look also at the chat. You have to scroll down in the question and answer box, because there are some questions for you. Thank you very much, Sanjay and Dr. Mohanty. Presentations from India. It's now the time for Indonesia, and today we had Dr. Linka Agria to tell us about the Smart Soil Sensing Kit from Indonesia. Linka, over to you.
Hello,
Yes.
Lucrecia. Hello.
Yes, we can hear you.
I think first I will give to Dr. Ladiani for the presentation.
No
Okay,
problem.
thank you, Lucrecia. Okay, thank you.
Dr. Ladiani Widowati from the Indonesian Institute of Soil and Fertilizer Standardization will tell us about lowland soil test kits and upland soil test kits. Dr. Ladiani, over to you. Welcome to see you again.
Okay. Thank you, Lucrecia. See you again. Yeah, we switch the topic first because I will have other activities. So I will share my presentation. Can you see it?
Yes.
Okay. Ladies and gentlemen, thank you for the time to present about Indonesian paddy soil test kit, or we call it also lowland soil test kit, or it is famous, we call it PUTS in Indonesian dialect. Okay, then yeah, consider about the food demand in line with the increasing population in Indonesia. It's about 276 million people who need food every day, 3 times a day. And also, as we know, paddy field in Indonesia in 2022 data, the area of paddy fields is about 7.48 million hectare, and then for the planting area equal to 10 million. And our rice productivity averages nationally is 5.2 ton per hectare. And as we know, the fertilizer price increased significantly. And we are looking for agriculture innovation technology. One is about the paddy soil test kit or nutrient management. And since 2004, we developed this and launched in 2004. But PUTS or paddy soil test kit is rapid, easy, relatively accurate, and simply, and also can be used for measuring the soil aeration, pH, and nutrient status of NPK. And this is provided with recommendation for NPK fertilizer for rice, maize, and soybean. Why we mention about maize and soybean? Because the third season, the second or the third season of the years, sometimes the farmer planting maize and soybean in the lowland. And this is the differences between the laboratory analysis and POTS. Of course, we make it simple, rapid, and also we try to make it the concentration is not as high as in the laboratory, and also the measurement using the colorimetric system. And the qualitative score is we divided become 3: low, medium, and high content. And then this is the procedure how to measure. Of course, the first one is about how to soil to sampling the soil. Have to represent the area that we have to that we want to analyze, and secondly is extraction, and after that measuring the nutrient content, and the last is fertilizer recombination. All is complete in one unit of POTS. And one unit can be used for 50 soil samples. And the price is about 1,500,000 rupiah, or equal to $100 US. And the principle is I already mentioned before. We have to extract the soil nutrient for the NPK and also for pH. And after that, we measure the nutrient level. This is the procedure. I think the farmer and the extension worker, they are already familiar how to use it. It's we make it simple and can be followed through the guideline book is completed in the unit of POTS. You take the 0.5 gram of soil into the test tube, and then add 2 milli N2, 2 milli N3, and mix it until drop out M3, and then for the fifth, this one, yeah, we use 0.5 milligram on M4 and CTMD, and then allows 10 for 10 minutes, and then we measure the concentration or the status of the nitrogen and compared to the color chart. And in the color chart, we completed the recommendation of urea. For example, for next slide, I think, yeah. For the clay content, the soil with the clay content 20 to 40% or above. So if our yield target is 4 to 5 tons per hectare, if the concentration of nitrogen is low, we recommended 250 kg urea, and for the clay content less than 20%, this one higher compared to the first clay content. And this is the recommendation of application, 2 times and 3 times, depend on the clay content. For coarse soil, yes, we have to split it become 3 times for the application. And also, it is better to increase the nitrogen efficiency if we measure the color of the leaf using the paddy color chart or leaf color chart. It is also completed in the unit. The LCC, we use LCC from IRRI. Okay, then we measure the P analysis. We take about 0.5 gram of soil and then put in the test tube, and we add 3 milli of P1 and mix using the glass stirrers, and we put a small of P2 and sink until dissolved, and then let's stand for 10 minutes and then we compare the P content with the color chart, and like in the screen is the concentration or the status for P is high, and the recommendation for the SP36 is 50 kg. And then this is the complete recommendation for low, medium, and high content. And then this is for potassium. The step is almost similar. Just follow the code of the bottle, K1, K2, and so on. K1 at the 2 milli of K1, still using glass stirrer, and 1 drop of Q2, set for 10 seconds, and then 1 drop of Q2, set for 10 seconds, and so on. Then let stand for 10 minutes, and then the color change depend on the concentration of potassium. And then we compare it with the color charts. And this is the comparison, and this is the recommendation. If we add the straw or without straw, it's different, because in straw, 5-ton straw is equal to the 50 kg of KCl. That's why if we use the straw or return the straw to the landfill, for the KCl we reduce 50 kg of KCl. Okay, this is for pH analysis. Because from measuring the pH, we can decide if we use urea or ammonium sulfate. For the soil less than 6, the pH, we recommend to use urea, but above 7, we recommend to use ammonium sulfate. Okay, the procedures are almost similar, 0.5 gram of soil, and then add the 4 milli of PS1, stir using the glass stirrer, and then add 1 to 2 drop PS2, set for 10 seconds, and then let stand for 10 minutes, and then the color appear, and we comparing with the color chart. And this is the gradation of the soil in Indonesia. And this is the recommendation. Yeah. For example, we recommended like using urea if the pH between this or below 7. If above 7, we recommend to use ammonium sulfate. Okay, and then this is the distribution in Indonesia from 2015 to 2023. Actually, it's already launched from 2005, but the complete data we have is 2015 to 2023. So already distribute whole of Indonesia. 0.0 here is not meaning no test kit distribute there, but because yeah, something like 0.04, something like that. So this is the total of the UTS already distributed to 20,000 for 44 unit for all of Indonesia. And who use it? This is the distribution, the extension agriculture, government, private company, provincial agency, IRD, and farmer group, and also for promotion. And this is the response from the extension agriculture. For example, like when they are using the PUTS, the recommendation of urea is 250, SP36 is 100, and KCl 50. It's obtained the rice production is 4.5 ton per hectare compared to the conventional. And this is response from the extension agriculture from whole of Indonesia. I will give another example. Like this. Yeah, Sarindi. For the recommendation using POTS is urea 200, SP36 is 75, and KCl is 75. The rice production is 6.3. So it means reducing the fertilizer is still increasing the production of the rice. And there is also other data is show the positive response of using the POTS. Okay, I think this is the last presentation of POTS. Is the price 1 unit is about 1,500,000 rupiah, or equal to $100. 1 USD is 15,000. Yeah, 50,000 rupiah. And the complete instruction can be accessed to YouTube through this link. Okay, thank you.
Many thanks, Ms. Ladiani. Please keep an eye on the question and answer box, as I will be giving the floor to Linka now to talk about the other soil test kits from Indonesia. Linka, over to you. If you can please be mindful with the time, because we are running a bit late.
Okay,
Thanks.
okay. Thank you, Lucrecia. And then continue to upland soil test kit. My colleague will present. Laili, please. Bu Neno. Okay, thank you.
Sorry, my connection is not good. So.
Okay. Good morning, good afternoon, everybody. I'm Laili. I'm on the behalf of Dr. Ladiani from Indonesia Soil and Fertilizer Standardization Institute. I would like to share about upland soil test kit, or in Bahasa we call it as PUTK. Next, please. Why PUTK was created? The speed and accuracy of fertilizer recommendation, which is plants cannot wait. Fertilizer efficiency is about price and availability. The agricultural and environment is protected from pollution. Soil productivity is increased and maintained. Next, please. The beneficial of soil chemical analysis test kit is quick, easy, relative accurate, simply for determination of P, phosphorus, potassium, pH, lime, and C organic requirement for upland. Next, please. Its PUTK component are one set of soil extracting kit, color chart, porting kit, and guidebook. Next, please. This is the differences between laboratory analysis and PUTK. Laboratory analysis, it takes a long time to analyze, extracting various forms of nutrient, various type of strong acid or base chemical, measurement with advanced tool like AAS, MPAS, ICP, and spectrophotometer, quantity figure, and high accuracy ppm and ppb. And for PUTK, it's a quick procedure. Only available nutrient from nutrient form should be extracted. Chemical with low acid, base, or salt concentration, colorimetric or color measurement, and then qualitative score, lower accuracy, low, medium, and high. Next, please. PUTK working principle: extracting soil nutrient, extract soil nutrient NPK in the soil solution. This nutrient can be used or absorbed directly by plants. Measurement or of nutrient level. Measurement are carried out using the coloring method. The measurement results are semi-quantitative, classified into low, medium, and high classes. Next, please. This is the procedure of using soil test kit. The first step is a method of taking soil sample and then extraction of soil sample. The process of measuring nutrient level and their determination, and then fertilizer recommendation. Next, please. For P determination of phosphorus P level. First step is put half a spatula of soil, add 3 ml of P1, stir with a glass stirrer for 1 minute, and then a pinch of P2, stir for a minute. And then let's stand for, next please. Let's stand for 10 minutes and then check using a P color chart. The next is K determination of potassium level. Put 0.5 gram of upland soil and then add 4 ml of K1, then homogenize. And then let's stand for 5 minutes. Next, please. Add 2 drops of K2, stir it, and let's stand for 5 minutes. And then add 2 ml of K3. Let's stand for a couple of minutes and observe the formation of white mist between two solutions. The last step is check using K level chart. Right? Next, please. Determination of pH. Put 0.5 gram of dry soil and then add 4 ml of pH1 extracting material, then homogenize. And then add 1 until 2 drops of pH2, then homogenize. Let's stand for 10 minutes. Next, please. Check using pH color chart. Add some drop of K until a permanent green color appears. And then check using color chart. Next, determination of the organic. Put 0.5 gram of dry soil. And then add 1 ml of C1, then homogenize. Add 3 drops of C2 and don't stir. Let's stand for 10 minutes. And next, observe the height of the foam form. Then check using the organic chart. Next, please. This is the PUTK distribution in Indonesia between 2021 until 2023. The highest distribution is in Java Island. Next, please. Yeah, thank you for your attention. The presentation will continue with Bu Linca about soil sensing kit.
Okay, I will continue to the smart soil sensing kit. Next, please. In Indonesia, the mainland is a lowland and upland. For the lowland, there is not swamp and swamp. And for the upland, there is acid soil, non-acid soil, and dry climate. Acid dry land is dominated in Indonesia. Next, please. Indonesia is the 4th highest population after China, India, USA. The increasing of population will follow by the increasing demand on food and land availability for agriculture. Next, please. Agriculture challenge. First, land conversion to non-agriculture function, about 100,000 hectares per year. Second, the need for nutritional and healthy food for urban community. And then the third, agricultural practices toward eco-friendly and sustainable technology. Smart farming is one best option to suit the millennial farmer. The lack of young farmers to continue agriculture business, and then the need for increased incentive to promote a healthy diet through smart agriculture, environmental friendly. Next, as we know that the agriculture 1.0 from ancient times to 1920, and a lot of manual labor traditionally done. More importantly, the fulfillment of family And then for the agriculture 2.0, since 1920 until 2010, use of tractor, machinery, fertilizer, and also seed, more production, time efficient agribusiness or industrial farming practices. And then for the agriculture 3.0, utilization of high technology in field of sensor, cloud, computing, specialized software. And then for the agriculture 4.0, development of artificial intelligence is cyber physical system, precision farming development, development of management information system. Next, this slide show another component of smart farming. For example, precision agriculture implementation. The main objective of precision agriculture is to enhance resource use efficiency for productivity, optimization, and sustainability. Precise input for activities need to be calculated or modeled adequately based on the agriculture resources monitoring data. Next, please. For the rapid analysis, in Indonesia, we have smart soil sensing kit, technology and innovation on improving agriculture production. Smart soil sensing kit is innovation technology from Indonesia Agency of Agricultural Research and Development. Smart soil sensing kit is an advanced technology based on near infrared that could be used for measuring soil chemical and physical properties, and is equipped with fertilizer recommendation. For the smart soil sensing kit, we have two versions. Version 1.0 has launched in December 2019 on World Soil Day celebration. And this is the picture of the version 1.0. Here we can determine the pH, potassium, phosphorus, and also nitrogen, carbon, and cation exchange capacity. Next, please. For the acquisition data, scanning and collecting soil data with NeoSpectra sensor, and then the step 2 model processing data output of sensor is data of soil nutrient based on reflection wave pattern. For the recommendation, the nutrient data proceed with certain equation to obtain fertilizer recommendation. And then for the storage, scanning data result can be saved on local storage or removed. For synchronization to cloud, scanning data result can be synchronized using internet modem. This is for the soil sample preparation, soil sampling in the field, and then I dry the sample, and then we ground and sieve the sample. This is the component, scanner and cell phone, and for the sample, we should first I dry the soil. Next, this is the process to use smart soil sensing kit. Scanning the process, and then step 2, scanning the result soil properties, and then the third, download the data. Next. The limitation of the smart soil sensing kit tested and validated from proceed soil sample should be eye dry and sieve. Limitation related to the use of near infrared technology apply. There is not on its development. The kit was developed with budget of Ministry of Agriculture. Update and validation is needed for improving the accuracy of measurement and the quality of the recommendation on plantation and horticulture crops. If you want to see the international scientific publication about the smart soil sensing kit, we already published with the title Developing a Soil Spectral Library Using Low Cost Near Infrared Spectrophotometer for precision fertilization in Indonesia. Next. This is our development team. Next. Thank you. I think I have a short video, Lucrecia, only 3 minutes. Is it okay for the smart soil sensing kit?
Okay, and then we close the meeting. Yes, please. Go
Okay,
ahead.
thank you.
Meanwhile, let me ask Dr. Mohanty, can you please answer a question that it's for your attention in the question and answer box? And also there is a general question for all presenters from Bhutan about the results variability or uncertainty. Thanks.
Oh, is it? Dr. Lucrecia, I think we have a problem with the video. I think I stop until here. Thank you.
Okay, thank you very much. Maybe we can share the link if it's available in the chat so participants can look at it themselves. I'm sorry we are running a few minutes late, and because I don't want to rush the last presentation of today on the soil test kits that actually would have been from the Philippines, the speakers from the Philippines kindly agreed on presenting about it tomorrow. Tomorrow is a bit packed, but we can spare 10 minutes for this. I think it's very important. So let's close today's session. Today, as you can see, was centered on introducing the topic and getting a hint on what is currently available on soil analysis in the region, both in terms of laboratory analysis, but also in terms of soil test kits. So I would like to thank all of you for your active participation and all speakers for their very good presentations. Thank you very much, really. So tomorrow, as I said, we will open with the presentation from the Philippines on the soil test kits from the Philippines. And then we will discuss about the possibility to have soil test kits harmonized at the regional level. We will provide some tips and tricks on soil test kits development, but also maintenance and use. And ultimately, there will be a scenario-based game that will touch also on what some of you mentioned in the chat on plant analysis. So I would like to thank you all again, and I really hope to see you very active at the session tomorrow, because tomorrow it will be very interactive. As I said, there will be a game and there will be more polls, so you will have the chance to really interact with us all. Thank you a lot, and see you tomorrow. Have a good rest of your day.
Thank you.
Thank you. Have a nice day.
Welcome.